Welcome to Pattern Play Math. And this is Tom Bizance, also known as MisterNumbers. Here I'm with my grandkids, and today we're going to explore one of MisterNumbers' ways to play with interesting number patterns. It's going to play with number wheels and addition, subtraction, multiplication, fractions, squares, lots of different ways on number wheels. So here is actually a number wheel that you're all familiar with. It's a clock, totally in a wheel, in a circle. And that's what number wheels are. This one keeps track of time, not numbers. So what we're going to do is a number wheel to 10, because our number system is based on 10. And we're going to wrap it around in a circle so that it's actually 0 and 10 on top, both. And we actually see number wheels other places other than clocks. These bike locks and gauges for electrical or gas or mileage all use number wheels to figure out exactly how much we've counted to. Now, number wheels are magical. They're playful foundation of visual patterns that teach math, all the basic math that you want to learn. So now we're going to deal with counting and place value. So a number wheel, it goes around to 10. Well, 0 and 10, so we need another wheel or something to keep track to go beyond 10. And what we do is we have a second wheel. And then we can go with this wheel up to 100. And we can actually use a series of wheels, like this car odometer, keeping track of miles, to keep track of how many numbers we want to keep track of. It's really fun. Now, kids want to play on these number wheels, so we actually have floor mats or paint on playgrounds to have the numbers on it so they can actually jump around and experience the patterns that numbers have. And here's a really fancy one, and it is pretty beautiful, and it actually has all addition facts, all subtraction facts, multiplication patterns, fractions, and more, all on that beautiful thing. Good math is beautiful. Now, many kids have strange ideas about math and numbers. Here's Calvin and Hobbes, their version. I don't think math is a science, says Calvin. I think it's a religion. Yeah, all these equations are like miracles. You take two numbers, and when you add them, they magically become one new number. No one can say how it happens. Either believe it or you don't. This whole book is full of things that have to be accepted on faith. It's a religion. Well, the reality is that on number wheels, you can see how they work. You don't have to take it on faith. So 0 and 10 are on the top, on the very top, and 5 is on the very bottom. And then next to 0 and 5 are 1, 4, 6, and 9. And we call that the tall box. And you see they're all horizontal and vertical lines? Yeah, and then there are 4 numbers left, 2, 3, 7, and 8. And we call that the wide box, of course. And that's all the numbers. And again, all the horizontal numbers and all the vertical numbers, let's take a look at those. So the first thing we're going to look at is horizontal numbers. In 9 and 1, in 8 and 2, in 7 and 3, in 6 and 4, and 5 and 5. And if all add up to 10, and 0 is also 10, so 0 plus 10 also equals 10. So you can see how that works right there. There's 5 and 5, and there's 0 and 10. Real easy. Now, these patterns, because we're looking at patterns and numbers, they show up on a number dial pad too. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9 on a dial pad. And notice that the outside numbers, the 1 and the 9, the 2 and the 8, the 3 and the 7, and the 4 and 6, all add up to 10. And then if you double 5, that adds up to 10 too. So there's all kinds of ways to do it. Now, it doesn't just work for 10. Let's look at 9s on the number wheel. And 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, they all create parallel lines that add up to the number 9. Really cool. There they are. They also can add up to other numbers. So here are 8s. So 0, 8, 1, 7, 2, 6, 3, 5. And 4 is all by itself. 4 and 4 are 8. And 9 and 9 are 10, 8. Cool. So now let's make 11s. And you can see actually 7 and 4 are 11. 8 and 3 are 11. 9 and 2 are 11. And 10 and 1, that's 10 as well as 0. 10 and 1 are 11, and 6 and 5 are 11. So there that is. Now, let's look at those vertical numbers. And 10 is the most important number. Those are the ones that are across from each other. And the next most important one, because our number system is based on 5 and 10. We have 5 fingers in one hand and 10 fingers all together. In 0 and 5, add up to 5. 1 and 4 add up to 5. 2 and 3 add up to 5. Again, railroad tracks. And this is also 10. So 10, 5, or 15, and 9, 6, and 8, 7 all add up to 10, 5, or 15. Really cool. So there's all of them, and you can actually see that that's level, and then it tips to the right, and tips more to the right, more to the right, more to the right, and then straight up and down. And it just keeps going around in a circle until it gets back up to level again. It's really fascinating, the patterns that you find in numbers. And this is actually a worksheet that I have kids fill out because they really love to see patterns and explore them, and they really learn from it. And they learn the whole sets of numbers that are there. Now this is my app for addition. Let's take a look at that. Wheel Math Plus. A 0 to 10 wheel shows addition patterns. Here we're adding 6 and 4, and then 7 and 3 are the next, 8 and 2, they all add up to the same, 9 and 1, and 10 and 0. All parallel lines add up to 10. And now we're adding 5 and 4, and 6 and 3, 7 and 2, 8 and 1, 9 and 0. Look on the left, they all add up to 9. 0 points to the answer. Now we're doing 6 and 6, and 7 and 5, and 8 and 4, and 9 and 3, and 10 and 2, all add to 12. You work your way up to 0, and that tells you your answer, what your answer is. We also actually do badges. I'll just show you this. For now, let's go for the 11s badge. We know 10 plus 1 adds up to 11. The next pair down below is 9 plus 2, then 8 plus 3, then 7 plus 4, and 6 plus 5. These railroad track parallel lines all add up to 11. Now we choose the 10s badge. We know that 6 plus 4, 8 plus 2, 9 plus 1, and oh yeah, 10 plus 0. 7 plus 3 is the only pair across from each other, and then 5 is all alone, and 5 and 5 are 10. Yeah, so you can see how you can really learn all the numbers that add up to a number on the number wheel. It's really pretty cool. Now, we can also, once we learn all those numbers and play with those numbers, subtraction really fits in well, because if we want to subtract from 9 on the number wheel, or 19, we can just go up to the 9s wheel. And if we go up to the 9s wheel, we can take a look at that, and we'll see that, oh, there they are, 0, 9. So 9 minus, let's say 9 minus 2, and the arrow points right to the answer. 9 minus 2 is 7. 9 minus 6 is 3. 9 minus 4 is 5. It works for all numbers. And so subtraction enhances and helps addition, and they both help. Addition and subtraction help each other. It's really pretty cool. So here are the number wheels out on a possible playground level where kids can play on the blank ones and play with these as well. And now let's play with multiplication on number wheels, because there's really cool patterns here. And there's it on the playground, and you can take a look at these. So this is going around by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is going by 2s. 2, 4, 6, 8, 10, creating that nice pentagon, or a house. Kids think of it a lot of times. And then the 3s do this starburst pattern, which is pretty cool. And then the 4s Kids really love the 4s. So 4, 8, 12, 16, 20. The last digit, make the star. And kids love to learn to make the star, and they're learning their 4s times table. And then the 5s, kids are amazed when I ask them to do the 5s, and they don't know what it'll look like. Well, it's just a yo-yo, 5, 10, 15, 20, 25, 30. And when we go 6s, we go right back to this one, because if you go around 6, the beauty of the number wheel is you can go around 6. You can also go the shortcut going back 4. If you go those 6, go add another 6, and you can actually go around 6 this way, get to 12, or you can go back to get to your 2 and know that you passed the 0. That's 12, and then you go around another, and you're at 18, and then you go another, you're at 24, and you're at another 30. Here's the 7s, actually are the same thing. 7, 14, the last number, 21, 28, 35. It works for the 3s, 3, 6, 9, and for the 7s. All the numbers that add up to 10. So then our 8s become as easy as the 2s. So 8, 16, 24, 32, 40. We'll get into that later. You can see how that works. And the 9s actually are as easy as the 1s backwards, almost. So you go around 9, well, you can just go back 1. 9, go around 9 more, you go back 1 to 18, 27, 36, 45, 54, 63, 72, 81, 90. That's how it works. Really cool. So on a playground, we might have one like this that just kind of shows kids all the options of if you want to move 2, you're either adding 2 or subtracting 8, or subtracting 2 or adding 8. It just depends on which way you're going around the wheel. And the 4s, same thing. There's a fancy one that you can use for doing the 4s on a playground. And you can do it on chalk, or you can just paint it. But chalk is really fun too. And here's the 5s. And actually the 5s are pretty interesting, because you go 5, 10, 15, 20, 25, 30, and you're going exactly halfway around the wheel. 5 this way, 1, 2, 3, 4, 5, and 5 this way, 1, 2, 3, 4, 5. Halfway around the wheel, you add, and you also, if you start with 25, you can subtract going around this way. 20, 15, 10, 5, 0. And you can do that from any number. So here you're at 1, 6, 11, adding 5s, add 5 to 16, add 5 to 21, add 5 to 26, add 5 to 31, add 5 to 36, and you can go backwards. 31, 26, 21, 16, 11, 6, 1. You may have to watch that again or kind of play with it yourself to really get it, but it works with all numbers. So here you are, 2. You go add 5 to 2, and you end up with 7. You add 5 to 7, 8, 9, 10, 11, 12. It ends in 2. Add another 5, 17, 22, 27, 32, 37. And kids jump halfway across the wheel. They love to jump across the wheel doing that. It's really a lot of fun. 3s and 8s do the same thing. 3, 8, 13, and 4s and 9s do the same thing. So it works for all numbers. Adding or subtracting 5 from any number is a real nice shortcut for kids to have. And there's 3s going clockwise, 3, 6, 9, or you go backwards, 7, 14, 21 for 3s and 7s. You may have to look at that a while before that makes sense to you. But it's just pretty cool. And that's those. And this is a wild one, because these that we just showed a little while ago, these are the numbers that add up to 9. So 9, 8 and 1, 2 and 7, 3 and 6, 4 and 5, all add up to 9. But if you say the numbers going around this way with this number first, you have 9, 18, 27. 9 times 1, 9 times 2, 9 times 3. 9, 18, 27. 36, 45, 54, 63, 72, 81, 90. I told you it was magic, didn't I? And here's the one circle. And again, you can go around 9, 18, 27, 36. it really is magical how the numbers have so many patterns that are really fun and interesting. Let's look at my multiplication app, Wheel Math, Wheel Fun.
2. And there's our line. From 2, we move 2 more spaces, so we'll touch 4, and then 6, and then 8, and then 0.
2, 4, 6, 8. Who you appreciate?
We go around from 0 to 8, but the line goes directly back 2. Go around 8 more from 8 and you're at 6. Since you pass 0, you add 10 and you're at 16. Around 8 more takes you to 4. You went past 0 again, so the big numbers now say 24.
And we're going to cut it off there, but you can see that that's actually creating the same house or pentagon backwards, with the 8s as the 2s goes forward. Now let's look at fractions, because number wheels also help us really learn fractions. Look at a number wheel and see we have 10 numbers around it. In here, we're actually going around to 5, and that's exactly 5 out of the 10 numbers, or 5/10. It really is pretty cool. And this is 2 out of the 10. And fractions are really dealing with whole and half. So you have to see, there's 10 numbers altogether, and we're actually looking at 2 of those 10 numbers. That's how fractions work. Kids don't understand how that works, and so number wheels help them really get it. And because fractions are whole and part, our whole can be anything. So here we can use our clock, and we have 12 numbers. And actually, when we divide that up, then it's a lot easier. We can actually do halves, we can do thirds, we can do fourths, we can do 6 on a clock. So a clock can be handy too as a number wheel. Now this is something where we use, these are decimals, and like 0.1 is a decimal, and then 1, we call that 1/10. And then this is also 1/10 as a fraction. Same thing. In a dime, here's a dollar, and this is 1/10 of a dollar bill, and a dime is also 1/10 of a dollar bill. This box, there's 10 boxes, and it's got an X and 1 out of the 10. That's also 1/10. This has one triangle out of 10 possible triangles you could make on this number wheel. That's 1/10 there. And 10% is all of these. Those all represent 10%. So you can see that fractions and decimals and percents all show exactly, they're all related. It helps kids. Language is really tough for kids. So this really helps them tremendously in terms of doing that. And here's another one with 4/10. So you have 4/10 as a decimal, 4/10 as a fraction. We can reduce that down to 2/5. We have 4 dimes, and then 4/10 of a dollar, and 4 squares, and 4 triangles, and they all equal 40% of the whole. That's how that works. And these are some math frisbees that I use, and here's kids.
You're doing all the numbers that add up to 9.
I can't do it.
5 and 4, and then the numbers next to 5 and 4.
3 and 6.
Yep.
7 and what's it called?
2. Yep. 7 and what's it you call it?
8 and
8 and 1.
a
Yep.
different color. Can I reset this?
And you can see how she's really young, and she couldn't even remember the number 2, the word for it, but she saw the pattern, and she knew how it worked. It's really fun to play with this with kids. And the angle is really important. So you can actually see that this is 10 if the line is like this, 9s if the line is like this, 8s if the line is like this, 7s, it all straight up and down are 5s. So you can actually see, you can actually connect 2 numbers on the number wheel and look at the angle and know what it's going to add to. All kinds of ways to really see how math works. Now let's look at squares. Now squares, if you square a number, it's square 1 is 1 then 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So if you look on the number wheel, you actually have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now, 6 squared comes right back to 36, 7 squared goes to 49, 8 squared goes to 64, 9 squared goes to 81, 10 squared goes to 100, 11 squared goes to 121, 12 squared goes to 144. It just continues on. It's really pretty fascinating how that all works. Yeah, so that's that. And what I do with kids is actually if you're at 0 from any number, if you go one step, we call that a step. If you go a long step, we call that a stride, going 2 numbers either way. And then a hop, a skip, and a jump. A hop, a skip, and a jump. And 5 is a jump no matter which way you go. It's really pretty fascinating to see how all this works. Now, we did it with whole numbers. We can actually put our decimal places in there because it doesn't really matter. This is tenths. The last circle shows tenths. And again, it works all the fine because all our number system is based on 10. It really works well for it. Now, on a playground or in your sidewalk in front of your house or however you want to do it, it's real easy to take a string and a piece of chalk, hold the string down, one end of the string down, and you can make a perfect circle like this. And then figure out how to put the numbers on it, and all numbers are above or below or to the side of other numbers, except for 5 and 0 are all alone on the top and bottom, but they're up and down from each other. Now, there are different ways to play with number wheels. So there are big floor mats, there are chalk circles, there are geoboards, there are laminated sheets, there are math flying discs. Make your own from scratch and play with pennies and dimes or fingers, because the more kids get active playing with it, the more fun they have, and the better they learn. So one thing that I use actually is geoboards. Now, I did these on my 3D printer, and this is showing all the 5s and 10s on this one, and this is showing the 4s and the 6s on this one for the multiplication patterns, and then this is showing addition patterns. If you have parallel lines, you're always doing addition. It's the way it works. It's, again, the magic of number wheels. And I have large geoboards off the 3D printer for teachers to show in front of a class. So there's lots of ways to do that. So squares. Now let's just take a look at squares, because squares, when we did the squares on the number wheel, remember it was 1, 4, 9, 6, 5. Ooh, that was the N on the number wheel. And then we go back 5, 6, 9, 4, 1, and 0. And there'd be a 0 up here, so it's exactly the same thing. And then we're down to 0, and again that 1, 4, 9, 6, 5. 6, 9, 4, 2, 1. And we've just created all the squares up to 20 times 20. And you can actually, these numbers, I'll just go through this. The numbers in front of those are 1, 2, 3, 4, and then they go up by 2s, 4, 6, 8, 10, 12, 14, 16. Really, it's that easy. And then it goes up by 3s, 16, 19, 22, 25, and then it goes up by 4s, 28. And then it goes up by 4s, 28, 32, 36, and 40. And it would continue 44, 48, 52, like that. And these are all one less than the squares. This is pretty amazing. It's pretty incredible. So if this is 9, then this is 8. 3 times 3 is 9. 2 times 4 is 8. 4 times 2 is 8. 2 times 2 is 4. 3 times 1 is 3, and 1 times 3 is 3. And here I'll just show you more of these. all the way down. These are all one less than the square on both sides. So all of a sudden you're learning your multiplication facts really an easy way. And then these green ones are actually 4 less. So 1 less than the square. These are 4 less than the square. Look up here. 9 minus 4 is 5. And I'm doing through this pretty fast, so you can sit with this for a long time and you'll start seeing how it works. But 1 less, 4 less, 9 less, 16 less, 25 less. It's really pretty cool how it works. So 36 minus 11 is 25. It works for all numbers, and then you can figure these out. I've had classes that figure it all out and work it all out. Really cool. So there's the squares. There's that math frisbee with the number circles on it. Kids play with these on different ways to play with that on the playground, and you can learn geometry. So you can figure out your angles and stuff. It's really handy to do that. And the tic-tac-toe squares, I also use those on a playground. So here's a playground, and this would be like the number circles on that, drawn on the playground. So you can actually, kids can jump around on those and really have fun. And that is some of the ways that you can play with number circles, and kids really enjoy the simplicity, and they understand how numbers work, the patterns of numbers. It's really cool. Thank you much. Goodbye.